Today we are going to start the new chapter, that is alcohol, phenols and ethers. Again, this chapter belongs to the organic chemistry part. It is having the 4 marks weightage with option 6. Write the weightage in your textbook. I will share this PPT with you. I want to make some changes. After the lecture, I will send you. Some questions are given. These are some questions which are asked for previous board exam. But I want to make some changes. Yes. Introduction part. Now, what is mean by alcohols and what is mean by phenols, I will explain with the examples. In case of alcohols, in 11th standard already we learned. In case of alcohols, OH group is attached to the carbon. Remember, these are the hydroxyl compounds. Hydroxyl group means OH group is directly attached to the carbon atom. And in case of phenols, the hydroxyl group is directly attached to the carbon atom of the benzene ring. This is the difference between alcohols and phenols. In phenols, OH is attached to direct benzene ring, and in case of alcohols, OH is attached to the carbon atom. It may be carbon-carbon single bond, or it may be carbon-carbon double bond. Depending upon the carbon-carbon single bond and double bond, again the classification of alcohols is done. Now, ethers, as the name of the chapter is alcohols, phenols and ethers. Firstly, we will discuss about what is mean by alcohols, what is mean by phenols, and what is mean by ethers. So you now understand the concept of alcohols. Alcohols are the organic compounds in which hydroxyl group means OH group is directly attached to the saturated carbon, that is carbon-carbon single bond. Also, this OH group can be attached to the carbon-carbon double bond also. In case of phenols, they contain OH group directly attached to the benzene ring. Then I'm coming to the ethers. Ethers are the compounds which contains central oxygen is there, and to the both side alkyl groups are or aryl groups are there. See here it is given ROR dash or ROAR, AROAR dash, this is given. Now the classification is given here, classification of alcohols, phenols and then ethers. These are classified depending upon the number of OH groups, mono, di, tri and polyhydric compounds. Mono, the name itself suggests it contains only one OH group. See here, this is a mono alcohol. This is called as monohydric. Monohydric means this contains one OH group. Dihydric means they contains two OH groups. And these are the trihydric means these alcohols contains 3 OH groups, same as phenols. See, this is a monohydric phenol which contains 1 OH group. Then this is a dihydric alcohols. This is dihydric alcohols and this is dihydric phenols which contains 2 OH groups. These are ortho position in halogen derivative. Also, I explained what is meant by ortho, meta, and para. 1,2 position is ortho, 1,3 position is meta, and 1,4 position is para. This is examples of trihydric alcohols. Trihydric alcohols. This is a above. See, OH group is directly attached to the carbon. That's why these are alcohols, and these are phenols because OH is directly bonded to the benzene ring. So this is a classification of mono, di, tri, and polyhydric alcohols and phenols. Monohydric alcohols are further classified on the basis of hybridization state. Two, monohydric alcohols are further classified on the basis of hybridization of the carbon to which OH group is attached. See the example here. This OH group, in case of primary, these are the primary alcohols, these are the secondary alcohols, and these are the tertiary alcohols. In this, OH group is attached to the primary carbon. Now, you understand the concept of primary carbon. what is meant by secondary carbon and what is meant by tertiary carbon. Again, within 1 minute, I will explain if you didn't understand the primary, secondary, and tertiary alcohol. If OH is attached to the carbon and carbon is attached to only one carbon, it is called as primary carbon. See, OH is attached to the secondary carbon. Secondary carbon means, again, this carbon is attached to another two carbons. See here, two R groups are there. And in case of tertiary carbon, OH is attached to the carbon atom and that carbon is attached to the another three carbons, 1, 2, and 3. This is called as tertiary alcohols, in which the OH is bonded to the carbon, which is sp3 hybridized. sp3 hybridized means that carbon-carbon single bond is there. Now, allylic alcohols. In case of halogen derivatives, already we learned the allylic alkyl halides in that chapter also. In this, allylic alcohols means OH is bonded to the sp3 hybridized carbon, and again this sp3 hybridized carbon is bonded to the carbon-carbon double bond. Again, this is primary, this is secondary, and this is tertiary. So allylic alcohols means OH is bonded to the carbon atom and that carbon is bonded to the carbon-carbon double bonded carbon. It is called as allylic. Then I am coming to the benzylic. These are also primary, secondary, and tertiary. Benzylic alcohols means OH is bonded to the carbon atom and that carbon is bonded to the benzene ring. Remember one thing here, if OH is directly bonded to the benzene ring, it becomes phenol. It becomes phenol. But in this case, OH is bonded to the carbon atom, which is sp3 hybridized, and that carbon is bonded to the benzene ring. That's why it is called as benzylic alcohols. Don't get confusion between alcohols and phenols. Alcohols are separate compounds and phenols are separate compounds, both having the different properties. Characteristics are also different. I hope you understand the allylic alcohols and benzylic alcohols. These are also primary, secondary, tertiary. Like this one. In this, it is a primary carbon which is attached to only one carbon. COH is attached to the carbon, but this carbon is attached to another two carbons, this one and this second. That's why it is secondary. OH is attached to the carbon, and that carbon is attached to the another three carbons here, 1, 2, 3. That's why it is tertiary. Benzylic alcohols also primary, secondary, and tertiary, like the previous one. If you understand the concept of primary, secondary, tertiary, it is very easy to understand these examples. Then alcohols containing sp2 hybridized carbon atom. See here in this example, OH is attached to the carbon atom. This is directly double bonded carbon. Such type of alcohols are called as vinyl alcohol. Remember the name. Vinyl alcohol, remember the name, in which OH is bonded to the carbon atom, which is directly bonded to the carbon-carbon double bond. Such type of alcohols are called as vinylic alcohols. Now, one homework is given for you. After the lecture, we have to solve this. What is given in this homework? Classify the following compounds as primary, secondary, and tertiary. If you understand the concept of primary, secondary, tertiary, you can classify this. If you have any problem to identify, then discuss with me after the lecture. Identify the allylic alcohols in the above examples. You can identify if the concepts are clear. Now, the classification, Avinash Rajput, you can contact me after the lecture. Don't raise your hand here. Yes, classification of ethers. Now alcohols are classified and phenols classification is already completed. That is mono, di, tri, depending upon the number of OH groups attached. Ethers, remember one important note here. This classification is many times asked for board exam. Remember, this is asked for 2 marks. So make a note in your notebook or textbook there. Classification of ethers is asked for 2 marks. Many times it is asked for board exam. Ethers, these are the organic compounds which contains one oxygen centrally, and to the both sides R groups, R groups means alkyl groups or aryl groups are there. It may be R, it may be AR. R and R dash will be different or it will be same. So ethers are classified as symmetrical or simple ethers. See, it is clearly given here. Symmetrical means simple ethers or unsymmetrical means mixed ethers. As the name itself suggests, symmetrical means both the groups are same attached to the oxygen. And in case of mixed ethers or unsymmetrical ethers, the groups are different. So depending upon the two alkyl groups bonded to the oxygen, the ethers can be classified as simple or unsymmetrical ethers, simple ethers or mixed ethers. See this example, CH3O, CH3. Both the groups are same. This is one CH3, this is another CH3. That's why it is called as symmetrical ethers or simple ethers. Then in this slide, we can clearly see here, the one is CH3, another is C2H5 group. These are the mixed ethers. This is a C6H5, this is CH3, means two different groups are bonded. This such type of ethers are called as unsymmetrical ethers or mixed ethers. I hope you understand the classification of ethers. Now I am coming to the nomenclature. Nomenclature of alcohols, phenols, and then I will come to the ethers slowly. Common names. The common names are also called as tribal names. The common names of alcohols are obtained by adding the word alcohol after the name of the alkyl group, like ethyl alcohol, methyl alcohol, then propane alcohol. Alcohol word is attached there. These are the common names. Names of higher alkyl groups include prefix like iso, secondary, and tertiary. In case of IUPAC nomenclature system, you know the alcohols are called as alkenols like methanol, ethanol. This is one example is given, cyclobutanol. I will not explain in detail because in 11th standard we learn about the nomenclature system. Cyclobutanol. This is cyclobutane. This is a parent compound. 1, 2, 3, 4 carbons are there, and OH is bonded here. That's why it is called as cyclobutanol. If cyclopropane is there and OH is attached, it becomes cyclopropanol. See here, 1, 2, 3, 4, 5 carbons are there. It means it is a cyclopentanol, but OH is attached to the carbon atom. It will be considered as number 1, and this is number 2, C2H5. So the name is 2-ethyl cyclopentanol. The positions are important in case of IUPAC nomenclature system. If more than 2 OH groups are there or 2 OH groups are there, it becomes diol. If 3 OH groups are there, it becomes triol. 4 OH groups are there, it becomes tetriol. In this chart, clearly we can see common names and some IUPAC names are there. CH3OH. This is very familiar alcohol. We are using from last year. This is the common name is methyl alcohol. See, in common names, this methyl alcohol word is common in all the names. Only suffix we have to attach here. Methyl, ethyl, like N-propyl. See, why this is N-propyl? Because 3 OH groups are there. And in the straight line, that's why N suffix is attached. N-propyl alcohol. Then secondary butyl alcohol. Why it is butyl? See, 4 carbons are there. 1, 2, 3, 4 carbons are there, and it is secondary because this CH3 group is, this OH group is attached to the secondary carbon. Now I am coming to the IUPAC names here. Methanol. See, these are in case of IUPAC nomenclature system, alcohols are called as alkenols. Alkenol. So it is a methanol. This is ethanol. This is propane 1-ol. Now the position is important. Propane 1-ol, 1 indicates the OH is attached to the first carbon atom here. Now butane 2-ol. Butane 2-ol. Butane means 4 carbons are there. 1, 2, 3, 4. The rules are same. Select the longest chain containing the carbon atoms. So this is carbon number 1, this is carbon number 2, this is carbon number 3, and this is carbon number 4. The OH is attached to the second carbon, that's why it is butane 2 all. So my question to all of you, can you draw the structure of butane 3 all? This is homework. Just try this. Just try this. Can you draw the structure of butane 3 all? And after finishing the lecture, tell me butane 3 all is possible or not. Then the common name of this alcohol is isobutyl alcohol. Iso means the second carbon atom having the one CH3 group. So this is one first carbon. This is second carbon having one CH3 is attached there. This is called as iso group. In 11th standard, we already studied what is meant by iso and neo. Neo means there are two CH3 groups are attached to the second carbon. So this is isobutyl alcohol. Butyl means 4 carbons atoms are there. 1, 2, 3, 4. That's why it is isobutyl alcohol, or it is also called IUPAC name is 2-methyl propanol. Why it is 2-methyl propanol? Because select the longest chain containing the carbon atom. This is 1, 2, 3. On the second carbon, methyl group is there. That's why it is 2-methyl propanol. So my request to all of you, please go through this IUPAC names, because no any question will be asked for board exam on this IUPAC names, remember. But you should know the names of all the alcohols. See, I will take one example of this diols, because two OH groups are there. This is ethylene glycol, it is common name. If two OH groups are there, it becomes glycol. If three OH groups are there, the common name is glycerol. It is not alcohols. Alcohols are called when one OH group is there. If the two OH groups are there, it becomes glycol, and the three OH groups are there, it becomes glycerol. In common names, I am talking about the common names. In case of IUPAC names, if the two OH groups are there, it becomes diol. See, this is ethane 1,2-diol, because this is ethane. 1 and 2 carbons are there and two OH groups are there. That's why it is ethane 1,2-diol. See this example. This is propane 1,2,3-triol. Why this is propane? Because 3 carbon atoms are there, 1, 2, 3, and 3 OH groups are attached. This is propane 1,2,3-triol. Remember, if one OH group is there, it becomes alcohol. 2 OH groups are there, it becomes glycol, and 3 OH groups are there, it becomes glycerol. This is, I am talking about the common names and IUPAC names. Then crotonyl alcohol. Crotonyl alcohol means it contains carbon-carbon double bond. This is unsaturated alcohol. I am directly coming to the IUPAC nomenclature system. Butane 2-in-1-all. 2-in indicates second carbon atom having the double bond. In means double bond is there, and 1-ol means carbon number 1 OH group is there. So this is a 1, 2, this is a third carbon, and this is a fourth carbon. See, carbon number 1 OH group is attached. On the second carbon, double bond is there. That's why the name is but 2-in-1-all. Now I am coming to the nomenclature of phenols. Phenols, it is IUPAC name and also the common name. Common name is accepted by the IUPAC. Generally, in IUPAC nomenclature system, phenols are called as benzenols. But you remember one thing, phenols, it is also the common name, it is also the IUPAC name accepted by the IUPAC. So I think 1-2 position, 1-3 position, 1-4 position, you know the ortho meta para. It is already discussed many times. Now I am coming to the nomenclature of ethers. Remember, on nomenclature of ethers, question may be asked for board exam. Make a note there. Make a note there in your textbook also, and in your notebook also. Write classification is also asked on ethers, simple ethers, mixed ethers, and nomenclature 1 IUPAC or common name, it may be asked for board exam for 1 mark, because it is quite different nomenclature system. In common names and IUPAC names, again there are 2 types here. Directly I am coming to the example, so it will very easy to understand. See, ethoxy and methoxy, propoxy, I am coming to This one, what is mean by alkoxy group? Generally, it is called as alkoxy group. Oxygen is bonded. If oxygen is bonded to any alkyl group, it is called as a alkoxy group. See in this example, some examples are given here. Ethoxy. Ethoxy means this ethoxy CH3, CH2 group is attached to the oxygen. That's why it is ethoxy. See, there are 3 carbons, 1, 2, 3. That's why it is called as propoxy. This is isopropoxy. Means oxygen is bonded to this group. That's why these are called as alkoxy group. See this IUPAC nomenclature system of this ether. See this one is a CH3 group is attached, and another this one is 1, 2, 3 isopropyl group is attached. 1, 2, 3. This is isopropyl group, and this is methoxy. So the common name in common name is very easy, but in case of IUPAC nomenclature system, we have to use this methoxy, ethoxy. Parent alkane. Parent alkane means which is a longer. We have to consider as a parent alkane. This is a larger group. We have to consider as parent alkyl. I will coming to this chart. Then we will understand very easy. See the common names of these ethers. Dimethyl ether. Ether word we have to use in case of common names. Ether, like alcohols, in ethers also we have to use this word dimethyl ether. Dimethyl ether means there are 2 methyl groups. That's why it is called as dimethyl ether. This is ethyl methyl ether, because one group is ethyl, one group is methyl. Ethyl methyl ether. And see the IUPAC names. This is methoxy methane. Methoxy. This OCH3 group is methoxy, and alkane is methane. But in this example, this is methoxyethane. In case of IUPAC nomenclature system, the larger alkane we have to consider as a parent alkane. That's why it is a methoxyethane group is larger here. This is a methoxy, OCH3 is methoxy, and this is parent one, ethane. So in this example, see, there are 1, 2, 3. This is a propoxy group, and this is OCH3 is alkoxy. So the nomenclature system IUPAC, see, 1 methoxy propane. 1 methoxypropane. This is carbon number 1, carbon number 2, carbon number 3. On the carbon number 1, methoxy group is attached. That's why the name is 1 methoxypropane. Remember. Now see in this example, C6H5 means benzene. This is anisole. Common name is anisole. C6H5O CH3. And see the IUPAC name. This is methoxybenzene. Methoxybenzene, because OCH3 group is methoxy and C6H5 is a larger one. That's why it is called as methoxybenzene. In this example also below it is given. Below the example is given benzene. The common name is methyl propyl ether, because this is a phenyl and this is propyl. 3 carbon atoms are there. Methyl propyl ether, common name. And see the IUPAC name, 1 propoxy benzene. See, 1 propoxy benzene means this is carbon number 1 considered, and this entire group is called as propoxy. So the name is 1 propoxy benzene. If another locant is attached here, it becomes ortho. If it is attached here at 1,3 position, it becomes meta. And if it is attached at 1,4 position, it becomes para. So at your home, you can write many examples. Write the names of. Yes, I am coming to the common name and IUPAC nomenclature system of phenols. See, this is a normal phenol. OH group is directly bonded to the phenol. So common name is it is phenol. If one CH3 group is attached at ortho position, it becomes orthocresol. And see the also IUPAC name, it is 2-methyl phenol. Means OH group is attached to the carbon atom, it is considered as number 1. This is number 2, 2-methyl phenol. This is para-nitrophenol. This is common name because the nitro group is at para position is given here, 1, 4. This is carbon number 1. OH is attached to carbon atom, which is carbon number 1. And this OH is 10 minutes are remaining. So I will take first nomenclature system 4-nitrophenol, because the position is very important here. If the two OH groups are there at 1,2 position, it is a catechol, benzene 1,2-diol. Again, in case of phenols, it is considered as diols. 2 OH groups are diols, 3 OH groups are called as triol. See, in this example, I will give one example of triol. See, in this phenol, 3 OH groups are attached. 1, and this is 3, and this is 5. 1, 3, 5. Benzene 1, 3, 5 triol. Common names are very easy, but the IUPAC names are very easy, but the common names are quite difficult to remember. So go through it, make a practice at your home. What is mean by catechol? What is mean by resorcinol? Positions are important here. 1, 2 position, then 1, 3 position. 1, 4 position is called as quinol. Benzene 1, 4-diol. IUPAC names are quite easy because numbering is there, and 2 OH groups are diol, 3 OH groups are triols. This is a pyrogalol. Its common name is pyrogalol, but IUPAC names is benzene 1, 2, 3 triols. So the nomenclature part is completed here. Also, I have given some assignments depending upon the IUPAC nomenclature system. Answers are also given. So go through these slides. Then I'm directly coming to the preparation of alcohols. Now in halogen derivatives of alkanes, we prepared alcohols. These two reactions, first two reactions are again repeated from the chapter halogen derivatives of alkanes and arenes. The previous name of the chapter was halogen derivatives of alkanes. Now the name is changed, only the halogen derivatives name is kept. Preparation of alcohols. See, first one, from alkyl halide by hydrolysis with aqueous alkali or moist silver oxide. These are the two different reactions. First one is by using aqueous alkali, and second one is by using moist silver oxide. Again, I will explain in detail what is happening. See, the alkyl halide is taken here. Methyl iodide, you can take methyl bromide also, you can take methyl chloride also, you can take ethyl. Any alkyl halide you can take here. It is not compulsory to take methyl iodide every time. You can take any alkyl halide. Alkyl halide means R and X group. In the chapter number 10, already we learned what is mean by alkyl halides. So alkyl halides, when boiled with aqueous alkali, you can take any OH here, you can take KOH. Aqueous means these are dissolved in water. When it is boiled, what will happen? This is a nucleophilic substitution reaction, very famous reaction, SN2 reaction. See, this OH minus is a nucleophile. It is substituted here. This is nucleophilic substituted reaction, SN2 reaction. SN2 reactions are favorable in primary alkyl halide. So this is also primary. So remember these concepts. Again and again, I am repeating the concepts. What is meant by nucleophile? What is substitution? How it is substituted? So OH is substituted and we get the product CH3OH and Ki. Means this iodine is substituted. So this reaction is already completed in halogen derivatives. I will not explain again and again. The second one is very important because this reaction is taken with this AgOH. The name of this AgOH is silver hydroxide, but actually we can't prepare this silver hydroxide. We can prepare, but we can't store in a bottle like HCl. It is prepared in the laboratory. HCl is stored in the bottle, like NaOH it is stored in the bottle. We can't store this AgOH like because it is unstable. It doesn't exist. It only prepared at the time of reaction time. It is called as in situ preparation. In situ it is prepared. How it is prepared? Because when this Ag2O, this is a moist silver oxide, means silver oxide we have to kept in moist condition. Then at that time this AgOH is prepared. If this AgOH is prepared, it will be, this Br will be substituted. Again the OH minus is a nucleophile in this reaction. OH minus will be substituted here and AgBr, it is a byproduct. Many times this reaction is asked for board exam. Actually, it is asked from the chapter halogen derivatives, but you having the chance to remember. If you didn't understand in the chapter halogen derivative, you can understand here. So these are the two methods of preparation by using alkyl halides. Next one, by acid catalyzed hydration of alkene. This reaction is completed in 11th standard. The name of the chapter was alkene. If you see carefully your textbook of 12th standard, it is clear cut mention. Use the 11th standard textbook. See which instruction is given. I will read the instructions. See, yes, refer the standard 11 textbook chemistry, section number 15.2.4. This reaction is followed with Markovnikov's rule. But for understanding purpose, again, I have given this reaction. Don't open the 11th standard textbook. Already this example is given here. This reaction is given. See, what is this reaction? It is very easy. The name itself suggests it reaction is carried out with acid catalyzed reaction. Means acid we have to use here as a catalyst. Hydration of alkenes. Hydration of alkenes means OH group we have to introduce here. Say this is a simple ethene is given. This is H2SO4, cold, concentrated. H and OSO3H. It is bifurcated like this for understanding purpose. Markovnikov's rule I will explain. What is Markovnikov's rule? The negative, this is negatively, and this is H plus and OSO3H minus, negatively charged species or negative part of the reagent. It is attached to the carbon atom, which contains less number of hydrogens. But in this ethene, there is no issue of unsymmetrical because this is symmetrical alkene. So H can be attached here and OSO3H can be attached here. We get the addition product like ethyl hydrogen sulfate. This is OSO3H, ethyl hydrogen sulfate. After hydrolysis, this OSO3H is converted into H2SO4 and we get OH here. Ethanol. This is a simple reaction. We can take a example of propene here. You can take an example of butene here. You can solve many examples. You can take any alkene, add H2SO4. We get this intermediate. This intermediate after hydrolysis, we get the alcohol. So this is a very simple reaction. In 11th standard, this is completed. Make a practice of this reaction by taking different alkenes here. Ethene, you can take propene. If propene is taken, this Markovnikov's rule we have to use. Because propene is unsymmetrical, ethene is symmetrical, so there is no problem of attaching this OSO3H. But in case of, if you taken propene here, you will face problem where OSO3H group is attached. So this problem is solved by this Markovnikov's. According to the Markovnikov's, where it is attached, it will be attached to the carbon atom which contains less number of hydrogens. So this problem is solved. Then the next reaction is hydroboration. This is very important reaction. 2 minutes are remaining. I will explain in detail because this reaction is asked for NEET and JEE exam. Remember, those students who are preparing for NEET, JEE, many times it is asked for NEET and JEE exam because this reaction follows the anti-Markovnikov's addition. This is a quite difficult to understand. Say, hydroboration means what? Hydroboration means diborane we have to use in this reaction. Diborane, first time you heard this word, diborane, it is B2H6. And in tetrahydrofuran, THF, this is used as a solvent, so don't make too much attention to the THF. THF is only the solvent, that is a tetrahydrofuran. Like alkanes, then benzene, then alcohol. This solvent is used. Tetrahydrofuran is a non-reactive. It doesn't react with the reaction mixture. Like ether, it is used. Remember, like ether. In dry ether, it is used as a solvent. Like dry ether, it is used. So we have to take the 6 molecules of propene here. Diborane. See, this is diborane, B2H6, B2, and these 3 hydrogens. Again, it is doubled, B2H6. This is called as diborane. Hydroboration. Hydroboration means addition of B2H6. Remember, THF. So this is the first one. We get the trialkyl boranes. Trialkyl boranes. See, this is a tri. 3 alkyl boranes. Try alkyl boranes, we get the